Hello and welcome to a brand new series called Prove It, where we're going to be looking at a bunch of things from the Maths A level and further Maths A level syllabus, basically trying to find out why they're a thing, why we're allowed to use them, why do they work, because sometimes it's interesting to know that. So, kicking off today, first of all, with proving the quadratic formula, the absolute classic. And in case you can't remember, the quadratic formula is if you got the equation ax squared plus bx plus c equals 0, where a, b, and c are constants, then x can be found using the formula you can see on the screen in front of you. But before we continue on any further, a warning. Yes, worth pointing out that anything in this Prove That series is not going to be something that you need to know for the A level exam itself. These are all things that we're just looking at for fun. Now, it's worth pointing out there are some things in the A level exam that you do need to know the proof of, but I'll always make those things clear and separate from this series. They'll have the same branding as the rest of my actual tutorial videos, rather than these things which are just for fun. So, with all that said, let's get going. But something else I'm going to be doing in this series is I'm going to be trying to give you the tools to be able to have a go at these proofs yourselves, because it's sometimes fun to not just watch somebody else do stuff. It's fun to try stuff out yourself, get stuck in. So, therefore, what will we need for this proof? We will need to be able to complete the square, and then once we've completed the square, use that format to help us rearrange to make x the subject to the formula to ultimately solve the quadratic equation. So that's what you're going to need to do. Have a go. Pause the video now if you want to and have a go at that yourself. But if not, here's me doing it for you. So therefore, kicking off with the equation in its original form, and you might notice, of course, we've got a number, a coefficient in front of the x squared. So that means the first step we need to do as part of completing the square is factorize that a, that coefficient, out of the quadratic. Now, some people, when they factorize for completing the square, they only factorize that coefficient out the first two terms. I personally actually like to factorize that coefficient out of all three terms, which is consistent with what you'll see in any of my tutorial videos where completing the square appears. But it kind of doesn't really matter. Admittedly, for this proof, I would argue that actually factorizing the a out of everything does make it a bit easier, because ultimately later on we're just going to be dividing by a anyway. So, looking at what's going to be left inside the brackets, it's basically the quadratic now divided by a. So, ax squared will become just an x squared, bx will become a b over a, lots of x, and then the c will be divided by a to get c over a, and then, of course, closing the brackets and setting it equal to 0. Then we're going to complete the square, which, of course, is putting it inside the x inside some brackets with a squared sign, and then what goes inside the brackets is what was the coefficient of x divided by 2. So b over a divided by 2 becomes b over 2a. You then need to remember to take away that thing you've just put inside those brackets and square it. So, or rather, I should say, square it, then take away. So that will lead us with this. And then, of course, worth reminding yourself that we haven't done anything with the C over A in this line of working. So if you haven't done anything to it, it's got to remain there unchanged. Cool. Right then, on to the next step. So the next step would be just squaring out the, basically squaring the b over 2a that we've subtracted, and that will get you b squared, and then squaring the bottom is the 2a becomes 2 squared a squared, which becomes 4a squared. Okay, and then the next thing you might want to do is start to create a common denominator. Some people might like to move these things all into one big fraction. I'm going to keep them as separate fractions for the moment, but if you're feeling confident with effectively making them one big fraction, just be really careful with that plus sign that's in front of the c over a fraction we've altered if you do want to put it in one big fraction. So then, of course, multiplying out that fraction on the end will leave us with 4ac over 4a squared. Now is the moment where, as I said, it was helpful for me to have kept everything with the a factorized out of it, because now I can divide both sides of my equation by a. We can now start the process of trying to rearrange to make x the subject of the formula. So doing that, dividing by a leads us with this. And now moving the two fractions that are not inside the brackets over to the other side. This is the moment where this is the reason why I prefer to keep them as two separate fractions. But if you had multiplied them out, if you had kept them as one big fraction, then of course that would make this step a lot easier. So moving them across the other side, you'll get this. Okay, now we've got to undo inverted commas, the squared sign by using the square root. Of course, to do that, first we're going to want to have moved them onto one big fraction now. So as I said, some of you might have already done this by making it one big fraction earlier. But yeah, now square rooting both sides. But remember, of course, whenever you choose to introduce a square root to undo a squared, then you've got to make sure you put a plus or minus in front of the square root. Okay, then being able to simplify that, we're allowed to, by index laws effectively, square root the top and the bottom of the fraction separately. So that leaves us with that. And then the top's kind of got to stay as it is, basically. You can't re-simplify that. But the bottom, again, effectively by index laws, you're then able to individually separately square root the 4 and square root the a squared to leave us with a 2a on the bottom again. And we're almost there. The only thing we've got left to do is take away the b over 2a from both sides. And of course, to make it the format we're used to seeing, we've just got to make it one big fraction. And there you go. Amazing. The quadratic formula. We have reached the final answer. So with all that said, we have done it. Boom, pen drop moment. See you in the next video.